There are four fundamental forces in the universe: gravity, electromagnetism, and the weak and strong nuclear forces. Each of these is produced by fundamental particles that act as carriers of the force. The behavior of these particles and forces is described with precision by the Standard Model, with one notable exception: gravity. For technical reasons, the gravitational force has proven very difficult to describe microscopically. This has been, for many years, one of the most important problems in theoretical physics, to formulate a quantum theory of gravity. In the last few decades, string theory has emerged as the most promising candidate for a microscopic theory of gravity. The essential idea behind string theory is this: all of the different fundamental particles of the Standard Model are really just different manifestations of one basic object, a string. How can that be? Well, we would ordinarily picture an electron, for instance, as a point, with no internal structure. A point cannot do anything but move. But if string theory is correct, then under an extremely powerful microscope, we would realize that the electron is not really a point, but a tiny loop of string. A string can do something aside from moving. It can oscillate in different ways. If it oscillates in a certain way, then from a distance, unable to tell it is really a string, we see an electron. But if it oscillates in some other way, then we call it a photon, or a quark, and so on. If string theory is correct, the entire universe is made of strings, tiny vibrating strands of energy.